In this video here, we're going to continue where we left off, which was solving absolute values at number 13. So to solve absolute values, you might remember if you have an equal sign, that's where you split the equation up into two. Actually, before we do 13, let's fill out the table for 17, and that might help regain our memory. So 17 here is a nice table that describes all the types of absolute value properties that you might encounter. So anytime you have absolute values and it has an equal sign, this is a very simple type of solving. It's where you would split the equation up into two equations as x equals positive, whatever the number is, but as a positive, or you would have your second equation as a negative a. So a is some number, so you have a positive a and a negative a. You would split it up into two equations, drop the absolute value sign, and solve the equation. So this is if your equation has a equal sign. For this one here, I want you to notice here's the absolute value, and this is facing away. Anytime it's facing away, you might remember me saying that there is only one equation. Away is meaning there's only one equation. So when you write this absolute value and you drop the absolute value signs, you have it facing towards the A, but then on the tail of it, you're going to write it as one equation. So on the tail, you're going to add in the negative A, because you have to consider the positive and the negative numbers here. This one here is facing towards. You might remember me saying if the absolute value inequality is facing towards the absolute value, there are two equations. So x could be greater than positive a, or x can be less than negative a. So those are your two equations. And then we have the really weird ones here is when you have a negative constant. So if you have a negative constant, this is if it's saying x is less than negative a, then this cannot be true because absolute values always give positive numbers, and positive numbers should always be bigger than a negative number. So this can never happen. So if you've ever seen a inequality facing towards a negative sign and this is an absolute value, this means that there is no solutions. Whereas if you have the inequality facing towards the absolute value sign, because it's a positive value, this will be true because a positive number is always bigger than a negative number. So this is always true. X can be any number or all real numbers. Now that we can see the chart here, you'll notice the problems that we're going to be working on are similar to absolute value of x equals a, where you split them up into two equations, one positive, one negative. So now we're feeling more warmed up. Let's try 13. So this is an absolute value. It's equal to 5. So if I want to solve for this, I have to split it into two equations. 4x minus 3 equals positive 5, and 4x minus 3 equals negative 5. And so from here, I need to solve for x. And to solve for x, I'm going to try to move maybe the 3 over first by adding. And that would give me 4x equals 8. If I divide by 4, x is equal to 8 divided by 4 is 2. And so the first equation or the first solution here is x equals 2. Let's try to find the next one here. So if I add over 3 to try to get this x by itself, I would have 4x equals negative 5 plus 3 is negative 2. I'm going to divide by 4. If I reduce this fraction, that's negative 2 over 4. So if I try to reduce that, that's going to be negative 1/2. If you think about it, 2 and 4, they're both divisible by 2. 2 goes into 2 one time, 2 goes into 4 2 times. So that's how I was able to reduce it down to negative 1 over 2. So that there is my final answer. X is equal to 2 and negative 1/2. And that's it for that problem. So for 14 here, I want you to notice that this absolute value has a lot of things outside of it, as a 5 and a negative 10. Whereas this one didn't have anything outside of it. So it was, when you don't have anything outside, you can go ahead and split it up into two equations. So because this absolute value is by itself, you can split it into two equations. But this one here, I can't just go ahead and split it up. I have to try to get the absolute value of x plus 2 by itself first before I can split it into two equations. To do that, let's take a look. We have a 5 and a negative 10. To get rid of this 5, this 5 is multiplying the absolute value, so to undo it, I have to divide. And this is a minus 10, so to undo it, I have to add. So in general, to figure out what to move first, it's usually whatever's furthest away. So if this is your absolute value, the 5 is right next to it, whereas the 10 is a little bit further away. So we'll need to move the 10 first by adding it to both sides. So that cancels. Now we have 5x plus 2 in absolute value. 15 plus 10 is 25. I'm going to need to divide by 5 because this 5 is multiplying the absolute value. So undoing it, I need to divide. And so I have x plus 2. 25 divided by 5 is 5. And then I'll just split it into two equations. I have x plus 2 equals 5. And x plus 2 equals negative 5. And then from there, all I need to do is solve for x. So x is right here. To move over this 2, I need to subtract the 2 off. So x is equal to, oops, didn't mean to write that in green. X is equal to 5 minus 2 is 3. So that's my first equation. My second equation here, if I subtract 2 to both sides, I bring down my x, and negative 5 minus 2 is negative 7, so minus 7. And so my answer here is x equals 3 and x equals negative 7. And there we go. Now let's talk about solving absolute values with inequalities, because that's a little bit trickier. But use the chart here to help you out. So this one says that you have an absolute value, and notice it's facing towards the absolute value sign. So if it's facing towards, you're going to need to split this up into two equations. So I'm going to have x minus 6 is greater than 8, or x minus 6 is less than negative 8. So anytime it's facing towards the absolute value, I want you to remember that it means split it into two equations, one that's positive, one that's negative. And when you switch signs here, the negative one, I'm going to flip the actual inequality sign too. So from here, I'm going to just solve. I'm going to add 6 to both sides, cancel. And so x is greater than 8 plus 6 is 14. Or if I add 6 to this side here, x is less than, let's see, negative 8 plus 6 is negative 2. And so my two answers here as an inequality is x is greater than 14 or x is less than negative 2, and we're done. This one here is facing away from the absolute value sign. So here's the absolute value. It's facing away. So it's just one equation. So that means I'm going to rewrite this equation and bring it down as x minus 6 is less than 8. But notice that you'll bring down the positive version, and on the tail end, you're going to add in the negative version of the number you're comparing it to. So negative 8. From there, you want to try to get the x by itself that's in the middle. So I'm going to add 6 to both sides. So that cancels. So negative 8 plus 6 is negative 2. Bring down the x. 8 plus 6 is 14. And there we go. That is my final solution. Because now x is by itself. So x is between negative 2 and positive 14. So we've already filled out the chart. Let's take a look at shifting absolute value function. So a lot of absolute value questions here. So when it says describe all the transformation for shifting an absolute value, I want you to go back to that template that I gave you guys. So when you're given an equation that's an absolute value, in general, there are a few components you need to look at. So one is the inside of the absolute value. Anytime you have an absolute value, if there's a minus sign on the inside, you're going to be shifting right. If it's a positive sign, you're going to be shifting left. On the outside of the absolute value, if there's a plus sign attached, usually this means a vertical shift, so plus means up, negative means down. And then the A here is representing a number, and that number is being represented for the slope. So for 19 here, we start off with figuring out the shift. Like this here on the inside of the absolute value says -4. Anytime you have a minus sign, this is going right. So this is going right 4 units. And then this +3 is outside the absolute value. So that means that you have a plus, so that is up 3. And so if I go from the origin, you always start at the origin, we're going to go right 4 up 3 and plot our point. So this is hitting at 4, 3. All right, to get our next points, because absolute values, when you graph an absolute value, generally looks like a V shape where you have your vertex here. And to get the V shape, you need 2 more points. And to get those 2 points to the side, you use the slope. So my slope here, here's my x. The number in front of x is technically 1. So my slope here is 1 over 1. We can always put 1 over 1 or any whole number over 1. So from your vertex, you're going to go up 1 over 1, plot, and connect the dots. And because we need to make a V shape, we've got to do it symmetrically. So we're going to go up 1 to the left. And so when I look at this here is my vertex. And what I notice is the lowest point on this V. So this is the minimum. And so there we go. We have 19 completed. Let's check out 20. So 20 here has a +3 on the inside. So positive means left. So I'm going to write left 3. This 4 here is a +4, and it's on the outside, so this is up 4. And it looks like we have a slope of -2, so our slope is going to be -2 over 1. All right, so let's start with plotting our vertex. So we're going to go left 3 on the origin, and then up 4, so right about there. So that's going to be -3, 4. Now to use our slope here, we're going down -2, so down 2 over 1, because that's a +1. And then I'm going to graph my lines. So I need to do it symmetrically, so I'm going to go down 2 over to the left 1. And there we go, we have our absolute value. Notice that this time this vertex here is sitting at the peak of the V, so this is a max. And there we go. So that's 20. All right, so let's talk about graphing inequalities on a coordinate plane. This is where you'll do the shading. So for these problems here, you need to make sure that the y is by itself. So notice that this one here, the y is by itself. So to graph this, we have to plot the y-intercept and the slope. So my y-intercept here is at 3. So I'm going to hit it at 3. So it might help if I label. So my slope here is -2 over 1. My y-intercept is 3, so my b value is 3. And the slope is -2 over 1. So my intercept is going to hit right here on the y-axis at 3. And my slope is going to make me go down 2 over 1. All right, before we connect the dots, let's figure out what type of line to use. So if you have inequalities here, let's just remind ourselves, anytime you have these signs, you're going to use a dash line. Whereas if you have these inequality signs with an equal, you're going to use a solid line. So for me, I'm going to need a dash line because there's no equal sign here. So I'm going to dash it. And then I need to shade. So this says that y is bigger. If y is bigger, think about the y-axis for a moment. All the bigger y's are in this section here, whereas this keeps going down to negative infinity for y. So I want to shade above the line, so right about there. And we're done. This one here is a little bit trickier because notice that y is not by itself, so you need to get it by itself. The reason why you do this is so you can get it in that slope-intercept form. So that way you can figure out what the slope is and the intercept so you can make an easy graph here. So to do that, let's try to get the y by itself by moving over the 4x first by adding it to both sides. So we have 8y is greater than 16 plus 4x. I'm going to divide by 8. And I'm dividing by positive 8, so it shouldn't affect the signs. So y is greater than, let's see, 16 divided by 8 is 2. 4 divided by 8 can be reduced to 1/2 x. So I'm just writing the fraction to the side of the x and just putting the x next to it. So 4 can be divided by 4, which is how I got 1. 8 can be divided by 4 twice, so that's how I got 1/2. All right, so I have my y-intercept. It's at 2. And my slope here is 1 over 2. So this is my slope. This is my y-intercept at 2. And so in this case, let's go ahead and plot them. So 2 is right here. And I'm going to be going up 1 over 2 since the slope is 1 over 2. And this one here has an equal sign. So I'm going to be drawing a solid line. And then from there, I'm going to need to do some shading. So this is saying that y is bigger than this equation. So if y is bigger, I'm going to be shading in the bigger y direction. So this is going to positive infinity. So if y is bigger, we want to shade in the positive direction for the y value. So I'm shading up. And that's it for the graphing inequalities. Let's check out the piecewise function, which is the last concept we've learned. So for piecewise function, they're functions that are made of several functions. So in this case, there are 2 lines here, so you have 2 functions. Here's the first, here's the second. Now remember that piecewise functions, we have one side that's in the inequalities that help you test out which equation to use, whereas the left-hand side is generally the equations that you can plug in your values. So what we have to do is figure out what x value we have. We have 7 as our x. So if x equals 7, which equations do we have to use? Well, 7 is bigger than 1, right? So x is 7 and it's bigger than 1. It's definitely not less than 1, so we have to use the first equation. So this one here, we're using the first equation. And so that means this 7 gets plugged into this x, so this will be 3 times 7 minus 4. So if I work this out, this will be 21 minus 4. And 21 minus 4 is 17. And so that there is my final answer. This next one here is at 0. So when x equals 0, that would be less than or equal to 1. So again, this is my x value, and I'm going to need to be using the second equation because I have 0, and 0 is less than or equal to 1, so it fits perfectly with the second equation. So I'm going to plug 0 into here, and so that's negative 3, plug in 0, plus 2. If I work this out, negative 3 times 0 is 0, plus 2 is going to give me positive 2 as my answer. All right, in the next one here, we have f of 1. So in this problem, we have the 1. Which equation actually can equal 1? Well, it's the second equation. So notice the second equation says that x is equal to 1. So I can use this second equation for 25. This is going to be the second equation, and I'm going to plug it in. So that's going to be negative 3 times 1 plus 2. So I plugged in my x. I'm going to work this out. So negative 3 times positive 1 is negative 3 plus 2, which is going to give me negative 1 as my final answer. And that is it for this review. I hope you found this helpful. If you have any questions, feel free to email me or ask me in class. Bye, guys.